All right, guys. So what we're going to do is we're going to look at another ROS bag, right? It's in that folder under question 3. It's called tutorial 4.bag, and basically we're going to load it onto MATLAB like we loaded the previous ROS bag. And this ROS bag has laser information, right, from a LiDAR, right, from a laser scanner. So basically the first two commands are pretty much the same. By the way, everyone can hear me, right? Sorry, I keep worrying. Yeah? And you can see my screen as well? Okay, cool. All in all caps. Okay. Okay, so basically the first couple of commands are pretty much the same. You say ROS bag, you load the ROS bag, and then you select the topic that you want to select. So if I run this, okay, sorry, I need to give the path to the ROS bag. It's here, cool. So if I run this, you can see that this ROS bag has a couple of topics. So the available topics are scan and ROS out. So scan is what we want to look at. So if you look at the laser scan information, you will have 35 messages inside of it, right? And what we're going to do is now read that information. So I'm going to read the first laser scan, just like before, right? And if I look at it, the first laser scan information, right, you will have basically two sets of data. You'll have ranges and you will have intensities, right? And you will have a minimum angle and a maximum angle, and these things called angle increments. What you mean by all of that is basically if you have a laser scanner, right? So we are looking at a 2D laser scanner, not a 3D one, right? So if you have a laser scanner like this, what it would do is it will send a laser ray like this, right? And then another one like, so it will take this laser and it will rotate this laser, right? So that you will get a field of view like this, right? Or if it's a 361, you get a 360 view, right? Actually, I'm going to imagine that it's like this. Oops. Okay, for now, just imagine it's not a 361, right? Imagine you only have a field of view like this, right? So this laser will kind of rotate so that it covers a certain field of view. So there will be a minimum angle here, right? I'll call that minus alpha, and a maximum angle here plus alpha, right? And this will obviously happen in discrete steps. So you'll have information coming from this point, this point, this point, and so on, right? So there will be a set of angle increments. Okay, it's difficult for me to draw, but you get the idea, right? So basically what you get is a set of points, right? You get an array with the depth of each of these points. So for example, if there was an object that was around here, the laser ray corresponding to this point will actually be here. It will bounce back and come here, right? So that depth information is here. So let's say there were, in your field of view, your field of view was say 120 degrees, right? That 120 degrees, let's say, is divided into 2-degree sections, right? How many points will you get? You will get 60 points, right? So your laser data will be an array of 60 points, right? And each array will give you the range corresponding to that point, right? Is that clear, or am I yeah? Is it clear how my explanation, or do I need to kind of explain a bit more? Did everyone understand? Yes? No? Okay. If anyone didn't understand, please tell me, because otherwise the rest of the question will be a bit difficult. Right, so what you're seeing here is you can see that there are 360 information ranges, right? And what is your minimum angle? Your minimum angle is minus 3.124 radians and plus 3.14 radians, right? So that is 3.14 is about 180 degrees, right? So this laser is a 360 degree scanner. It's ranging from minus 180 to plus 180. Okay, and each angle increment is 0.0175. So for example, if you divide 2 pi by 0.0175, you get 360 roughly, right? And also you'll have a minimum and maximum range of your laser as well, right? And each of those laser scans will have a small time increment between them that will go on, right? So what you will be getting then is, actually I might have a PDF that might explain it a bit better. Give me a sec. Okay, not really. Sorry about that. Anyways, I hope it's clear. But yeah, let's say you have your laser scanner like this, and you have a range reading to a particular object with range R, right? So this is your laser scanner, and it has given you a bunch of ranges, and let's say we are looking at one range value, right? And we know that the angle of that range value is about, let's say, theta to your x-axis, right? Now if your laser data is only giving this r and this theta, right? You need to convert it into Cartesian coordinates. You need to know where this point is in x and y, for example, if you want to plot it, right? So obviously, let's say this point is x dash and this point is y dash. X dash and y dash is pretty easy to find. You take the range, x dash will be r cos theta and y dash will be r sine theta, right? So your sensor information will be giving these r's and thetas, and you need to convert it into Cartesian coordinates by taking r cos theta and r sine theta, right? So what you do now is you need to, if you want to actually visualize this data that you're getting from the ROSBAG, you need to convert it into Cartesian coordinates. So that's also pretty easy because there's a function that will allow you to do that very easily. So you take that first laser scan, look at the first cell in it, which is where the data is, right? Just like in the image before, it's inside a cell, right? And what you do is use this function called dot read Cartesian. So what it does is it converts that laser scan information, which are just ranges and bearings, that's r's and thetas, into Cartesian coordinates, right? So once you do that, you can actually plot it. So if you take this and you plot it, the first column will represent your x values and the second column will represent your y values, right? So if I run this now, this is what the laser scan looks like, right? So this is some sort of room. It's a 2D laser scan. So you plotted all the ranges and bearings that you obtained from the laser scan. Cool. So these three things are basically identical to the question number 1 that we did, where we loaded a ROSBAG, read a topic, read the message. This read Cartesian is kind of like the read images function that we use for reading images, except here you're taking the range values and you're kind of converting it into Cartesian form so we can kind of plot them and understand them, right? Because the range values because the depth values we are getting are just the range and the angle, not the XY coordinates. Okay, so that is where is that? Sorry. Yeah, so that is basically question number 3, right? So question number 4. Can you guys try question number 4 from the explanation I just gave you guys? So question number 4, you have to use the data that is given here, right? Not the ROSBAG, right? So imagine there's a hypothetical set of data given in a laser, right? So imagine this is the ranges in the laser, right? And the angles range from -45 to +45. I've asked you to plot these, right? So you can't use the read Cartesian in that because you're not using a ROSBAG. You'll have to do the kind of convert it into Cartesian space yourself, right? So I'll give you guys a few minutes to try out question number 4.